Well, hello, 7 Blue. Prepare to have your mind blown again. I remember doing this in G6. We're going to be looking at L110, converting repeating decimals to fractions. Maybe you're already like, I know what you're going to do, Mr. Muir. You're not going to shock us again. Yeah, it probably won't be very shocking. But remember this. Do you remember? Do you remember what we said? What is 0.9 repeating compared to 1? Do you remember? Okay, well, 0.9 repeating is a repeating decimal. So we're going to walk through that process again. So if you remember what we did back then, is we said, okay, x is equal to 0.9 repeating. Sorry, I'm just saying that. It's just a visual thing. 0 and 9/10 repeating, 9/10 repeating. Then I'm going to multiply both sides by 10. So on the left side, I get 10x. On this side, multiplying by 10 means I'm going to move that decimal once to the right. So that would give me 9 and then that 9 is repeating. Then if you remember, what we do is we take this original blue thing and we subtract it off. So we're subtracting off 0 and 9/10 repeating. On the left side, I would get 9x. Hopefully you'd agree. And on the right side, I simply get 9. And if I divided both sides by 9, I'd get x equals 1. And that's why we can state that these are equal. Mind blown again. That may have been boring because we did experience that once. I don't think I made you write it down back then, though, but this is your time. Write it down if you didn't. And let's see if we can practice that. So one of the fractions we're aware of that turns into a repeating decimal is 3/11ths. And we've looked at how those 11ths are just so cool that they double out, right? And if you forget what that was, then you can just do it right here. So that would be 3 divided by 11, put the decimal, you know what to do here. Like, you shouldn't be watching me. But you should come out on the closing end that this is equal to, and maybe you need to get this far to go, oops, it's going to start to repeat. And you go, okay, so this is going to be 27/100ths, right? So we know that. We know that to be true. Today's lesson, though, is not taking a fraction and turning it into a repeating decimal. It's the other way around. It's, can I start from here and end up here? Now, knowing our answer is sometimes helpful because it proves it to us. So let's do this one. I'm going to make x equal to... Oh, so you might go, well, what if I have 2 repeaters? Because that's what we have here. So what I'm going to suggest is that you clear it to the repeating pattern, to end that repeating pattern. So because there's a repeating pattern, then I need to kind of consider that. I need to repeat it out to 2. So that means, so I'll start with this, x equals 0.2700 repeating. Then, because of these two things, that's my repeating pattern. Instead of multiplying by 10x, like I did back here, I'm going to multiply it by, yep, you guessed it, 100x. Then, what would that do? Well, that would move my decimal place twice to the right, so I'd end up with 27 and 27/100ths repeating. And then I'm going to subtract off that original x, 0.2700ths repeating. And I should end up with, you said it, 99x equals 27. Then I'm going to divide both sides by 99, 27/99ths. And then I think about greatest common factor, which would clearly be 9. And I divide them both by that. And guess where I end up? Boom! Back here at 3/11ths. And so that's kind of our goal. Now, could they more complex it out? Well, a little bit. Let's check this one out. So here we only have one number to the repeating pattern. It's my suggestion that you always go out to kind of clear it, to move it out so that the very next number is the new pattern. So what I'm going to do here is going to say m equals 0 and 16/100ths repeating. Then I am going to multiply by 100 because of the presence of those two, because I want to clear it, if you will. And that'll give me, if I move it over twice, I'd end up with 16 point, and don't say 1, because the 1's not repeating. It's the 6 that is repeating. Now, this is where it gets a little tricky, and there's different ways. I don't really like your book's choice, so I'm going to show you my choice, and you can compare it to your book. But I'm going to go ahead and subtract. So this is what your book might suggest. Subtract it by our original, and that's what we did before. But I feel like that can be a little confusing because there's no space in that 100th spot in the green. So instead of doing that, I just erased it. You can erase it too. I'm going to actually subtract by 10m. And what that'll allow is me to move that decimal place from the purple one over once And I'd end up with 1.6 repeating. And notice how that lines up. It's just a little cleaner. And I'm going to still have to reduce, but they have to do something other than reducing when you look at their plan. I don't like their plan. So 100M minus 10M is clearly 90M. And then 16 minus 1 is 15. I'll divide both sides by 90 and end up with 15 90ths. I think about my GCF, and I know it would have to be 5. So 15 divided by 5 is, I put 1. I'm sorry, not 5. Blah, my brain not working. I was thinking about the last problem. So 15 and 90, its GCF is 15. So I'm going to divide them both by 15. 15 divided by 15 is 1. And 90 divided by 15 is, guess what? 1/6, which might be a memorized fact for you. I actually kind of know some of my 6s. So they do repeat, though. So that can be a little bit problematic. So yeah, that's kind of how it works. Now, you know Saxon, you think they just stop there and maybe give you a couple more practice problems of the same ilk, but no. Now they want you to turn on that brain. So please write this down. The theoretical probability of rolling 12 with 2 number cubes is 0 and 27 thousandths with the 7 repeating. About how many times would you expect to roll a 12 in 180 rolls? Now, clearly, by virtue of the lesson itself, we know we have to take that repeating decimal and turn it out, right? Turn it into a fraction. So let's work on that now. We'll say that m is equal to 0.027 with the 7 repeating. Oh, I didn't write that. I mean to write with the 7 repeating. Please write that in. But I'll have to mess up later. So put a little vinculum, thank you, Olivia, over the 7. Okay, so now I'm going to multiply by, what do I need? This is where I'm going. Okay, so I need 1, 2, 2, 3. So I'll multiply by 1,000. 1,000 m equals, and I move the decimal place over 3 times, and I end up with 27 and 7 hundredths. 7 tenths repeating, yeah? I'm really messing up. I think I'm nervous. Someone's watching me. Okay, then here, because again, I want to kind of deal with that idea, I'm going to multiply by 100m. And this is just a choice I make to kind of get me set up for something like this that's nice and clean. Because if I multiplied that blue by 100, then wouldn't I move that decimal place twice to the right? And I'd end up with 2.7 tenths repeating. And that's nice and clean. I like it clean. Then I'm going to subtract. So 1,000m minus 100m is 900m. And then 27 minus 2 is 25. I'm going to divide both sides by 900. And I get m equals, there's 4 25s in each 100, so that would be 1/36. And you might go, oh, done. Woo, wipe that brow. But you're actually not done. Because remember, they want to know how many times would I expect to roll a 12 in 180 rolls. Now that I've got this, I can take that 1/36 and multiply it by the number of rolls to determine how many. And again, you might go, is there cross-canceling? Maybe you just start dividing by 2, dividing by 2, dividing by 2. But actually, yeah, 36 does go into 180. And if you want to work it out, it goes in exactly 5. There it is, 5. Therefore, I could say, well, I would expect it to roll about 5 times. And after 180 rolls, you know what? Maybe this could be a project. Do you have 2 dice? Do you have time? Would you be willing to sit there and roll those 2 dice 180 times and see if it comes out a 12? 5 times? I'm willing. We're going to do sticker tour at the end of the year. We're going to do it all safe-like. We're going to social distance and wear our masks. But I know I owe you some stickers. So I will give 5 stickers to the person who actually does this experiment. And I want to know how many times the 12 came up. That would be 2 6s. That would be fun. You need 2 dice, though. Hopefully you got them. If not, Amazon can help. And I'm now a stockholder, so I wouldn't mind you ordering dice from Amazon. Other than that, it is Odin's Day. Therefore, you have regular old homework. HW110. We are testing tomorrow, and I know you'll do well. Bye. Take care.